Hello, in this video, we are going to study about the chapter Midpoint Theorem. So first we'll look at the statement of the theorem. So the statement says that in a triangle, if you're joining the midpoint of two sides, then the segment will be parallel to the third side and it will be half of the third side. So what does that mean? So consider a triangle here. So I'm going to name the triangle as ABC. Point D and point E are the midpoint of AB and AC respectively. Then when we join this segment DE, so this DE is parallel to BC and DE is half of BC. So if BC is 6 centimeters, then this will be 3 centimeters. So this is the theorem 1, that is the midpoint theorem. So remember, this part will be given to you and this is the proof. Okay, so in any triangle, we can take one more example here. So if this is a midpoint, then the line joining the midpoint will be parallel to the third side and it will be half of the third side. Okay, let us look at the converse of midpoint theorem now. Yes, so for the converse of midpoint theorem, what we have is a line which joins the midpoint of one side and it is parallel to another side, will be passing through the midpoint of the third side. So this is the property. So let's see what it says. This is a triangle. This is triangle ABC. Okay, as I told you in the earlier part, this part is given to you. D is a midpoint of AB. And you have DE parallel to BC. Okay, if this is given, so it says E is a midpoint of AC. So this is called as converse of midpoint theorem. So what does the converse of midpoint theorem says? So if you have a midpoint of a side and that is parallel to one side, that means this point is a midpoint. Okay, so this is a midpoint. There are some more properties that we can have a look now. So the next one is equal intercept theorem. So in equal intercept theorem, we will look at some parallel lines like this. Okay, so let us call these parallel lines by names. Okay, and this is L, M, and N. So we have line L parallel to line M, parallel to line N. Now I'm going to draw a line which is cutting this line. Okay, so what points does it cut? So we'll call that as A, B, and C. If it so happens that these are cutting equal intercept means what? AB is equal to BC. So if AB is 2 centimeters, BC is also 2 centimeters. If this is true, okay, if this is given to you or if it is true, then what it means, we can draw any number of other lines like this, and these lines will also have equal intercepts. So that means if this is D, E, F, or this is R, S, T, and they are going to cut equal intercepts. So these intercepts are equal. Okay, so if this is given, then you will have DE equal to EF, and here you will have RS also equal to ST. So suppose this is 1.5 centimeter, this is also 1.5 centimeter. If this is 3 centimeter, then this will also be 3 centimeter. So this is called as the equal intercept theorem. Okay, so they are making one line makes an equal intercept. That means all other lines will make equal intercepts. Now the same can be extended to a trapezium. So let me draw a trapezium here. So for a trapezium, you know that opposite lines, one side, okay, one pair of opposite sides are parallel to each other. So if I join the midpoint, so let us label this trapezium as A, B, C, and D, and this is E and F. Okay, so this is a midpoint. So what can be shown? Okay, you can just extend this and apply midpoint theorem and or equal intercept theorem. So what basically the property we have to prove, okay, is this. So what does it say? That EF is equal to half of AB plus BC. Okay, so the segment joining the midpoint of non-parallel sides of a trapezium is parallel to the third side and equal to half of their sum. Okay, so it is parallel and it is equal to half of their sum. So that's given over there. So these property can also be used to solve questions based on numbers. So for example, if it is given to you like this is 4 centimeter, this is 12 centimeter, and then what is the length of this side? So that is half of 4 plus 12, so that will be 8 centimeters. So this is one property which is called as trapezium application. So now we have discussed the properties of midpoint theorem, its converse, equal intercept theorem, and trapezium application. Now we go to the questions. So I would like you to pause the video, read the question, try to draw a diagram, and give it a try solving it. And then you can play it and see how the solution is evolving. So this is triangle ABC, and M is a midpoint of AB. A line through M parallel to BC meets AC at N, okay? And it is given to you that BC is 7 centimeters and AC is 5 centimeters. So this is 5 centimeter. You have to find MN and AN in triangle ABC. M is midpoint of AB. Okay, so this is given to us. And MN is parallel to BC. This is also given. So therefore, I can say that N is midpoint of AC. N is midpoint of AC. And the reason I'm going to write is converse of midpoint theorem. Okay, so this is not the midpoint theorem, but it is the converse of this. So therefore, what do you get? We get that N is a midpoint. So therefore, AN will be half of AC. So that will be half of 5. And we get AN equal to 2.5 centimeters. Okay, so this is one of the things that they had asked us to calculate, and we have got that. Now, the converse of midpoint theorem also tells us that MN will be half of BC. Okay, so MN will be equal to half of 7 centimeter. And so we get MN equal to 3.5 centimeter. So over here, the reason is same, and that reason is converse of midpoint theorem.